So the question is, do superhosts charge lower prices? We can answer this by using the two-sample t-test that we learned about in lecture 4. And let's say that you have two groups. You have group T, true for superhosts, right? And you have group F for false. They are not superhosts. And you have a measure, your Y is the price for like a rental price, and then you just plot your data on this y-axis and for the superhosts, and you do the same for the non-superhosts. And of course, you can then calculate a mean and look if the difference between the means are statistically significantly different from 0. Okay, so what you first need to know is what is the null hypothesis and the alternative hypothesis. Okay, so, and of course, I like to formulate the alternative hypothesis first, because that's what we are interested in. So what we are interested in here is to check whether the superhosts, the average listing price, the population average listing price for the superhosts are lower than, or is lower than the average listing price, the population average listing price of the non-superhosts. Okay, and to exhaust the possibilities here, we have to let's see. We have to have a null hypothesis of the population mean of the superhosts is greater than or equal to the population population mean for the non-superhosts. Okay, and we can just do some algebra here. So we can just move the population mean for the non-superhosts over, and we can get a difference. So what we are actually testing is whether or not the population mean, oops, and then we have to do like this and this. We are testing whether or not the population mean for the superhosts is less than the population mean of the non-superhosts, and that would make this difference negative. Okay, so we have mu t is the population mean of listing prices. For superhosts. And the mu f is the population mean of listing prices for non-superhosts. Okay, so what do we need to know to implement this test? We need to know the sample difference. Okay, the sample difference. Which is the let's see, the oh, not S, it should be T. We need to know the sample average listing price for superhosts. Okay, and we need to know the sample average listing price, yeah, for non-superhosts. And then we get the sample difference, and the standard error of this sample difference is equal to, as you remember, the standard deviation of the data points here. Okay, so you can calculate the standard deviation of these data points for each group, and you also find the number in each group, and that would be the standard error of this difference. So this is the sample S is the sample standard deviation. Okay, so if you have the difference and you have the standard error of the difference, then you can implement the t-test. So, oh, that's not correct. That was the last frame. Okay, so for example, you can in Stata you can just calculate the summary statistics for each group, and you do that by plotting summarize the price if host is superhost is equal to, and that would imply the double equal sign, equal to T for true, right? So this is for superhosts. So T implies superhosts, and F non-superhosts. Okay, so what we get is the observations. That would be the N for superhosts, right? And then you have the standard deviation, the standard deviation of the superhosts, and then you would get the mean, the sample mean for the superhosts, and likewise you would get the number of observations, and you would get the sample mean of the non-super hosts, right? And these numbers you can just plug into the t-test of difference in mean, and what you get is that you get the standard error of the difference which is equal to the standard deviation squared plus the sample standard deviation squared for the non superhosts. And if we plug in the numbers, it's let's see, I've got my cheat sheet. Okay, so that would be 488.7631, and you square it, divided by 1114, and we check that, and you have the sample standard deviation here, and you square it, and you have the number of observations. Okay, and for the non-superhosts, you have a standard deviation, sample standard deviation, 478.6939, and you square it, divided by 7,292, and you find those two numbers here, the number of observations and the sample standard deviation. Okay, so, and this will give you an answer of 15.68016. Yeah, we can just put 2 where we have 4 decimals here. So now you have the standard error. Now we can find how many standard errors away from 0 is your difference. Okay, so here you calculate the t-stat, and that would be the sample stat minus the hypothesis value divided by the standard error of the sample stat. Okay, so this is x bar minus, let's see, it's the sample difference minus a cutoff value divided by the standard error of this difference. Okay, so and the reason why let's see, yeah, and if we plug in our numbers, we have the statistical value here, the sample average for non-superhosts. It's 861.0676. It's 861.0676 minus the sample average of the superhosts. It's 807.342. It's 807.342 divided by the standard error, which we found here. It's 15.6802, which gives you a t-stat of 3.4263. So the t-stat is 3.4263, which means that the difference in means is 3.42 times the standard error of this mean. Which means that it's highly unlikely to occur by chance, but we'll go to the critical value, and if we have the critical value, we find that by looking at a random variable, okay, and if we have, for example, a 5%, we want only a 5% chance of getting a more extreme result, and this is a one-sided critical value, which gives us a critical value of 1.64 and 49. Okay, so and this critical value is measured in standard deviations, okay, in standard errors, which enables us to say that, well, our 1.64 standard error would give us the cutoff value between having 95% of the occurrences on the left side of this value, and only 5% of the occurrences to the right of this value, whereas our difference is way over here somewhere, okay, 3.43. Okay, so our result is highly unlikely. So what we conclude is that the t-stat is greater than the critical value, which means that we reject H naught, which means that and the t-stat was 3.43 and the critical value was 1.64, which means that we reject H naught. We find evidence superhosts charge lower prices. Okay, so but what we need to think about is confounding variables. Okay, so what you can do is that instead of going through all these steps yourself, you can make Stata do the job for you. So you just plug in t-test price. Okay, so price is your variable, and you group them by is superhost or not. Okay, and you just type in unequal variances in case they do not have equal variance. So, and then you find the number of observations, the mean, and the standard error, or the standard deviation, I was going to say, and what you can read out of this table is that you have the standard. Well, you have the difference in means between the non-superhosts and the superhosts. It's 53.7, and you have the standard error of this mean. Okay, so and you also get the t-value. You also get the t-value, and you also get the p-value for the alternative hypothesis. That the difference is positive, and this difference is positive. This difference is positive if the superhosts charge less than the non-superhosts, right? And because this p-value is lower than 0.05. Okay, so this is lower than 0.005, which means that you reject H0. And here you have different alternative hypotheses that you check at the same time. You have the hypothesis, the one-sided hypothesis, that the difference is negative, and you have the two-sided hypothesis that the difference is not equal to. So here you actually, by running one test, you can get the result for 3 hypotheses at once. Okay, so that's this video, and next time we will look at confounding variables.